Hello and welcome everyone. In the previous video, we discussed extreme values of a function and that they are useful in finding the best way of doing something. Here, we will try to design a cost-effective water tank that is made of glass and that will have square base and an open top. And the requirement is that this tank should be able to hold 1 gallon of water. Let's see how we can design such tank. We know that 1 US gallon is equal to 0.133 cubic foot, and we want a tank that has a minimum volume equal to this amount to hold 1 gallon of water. This is the constraint. We can also write the surface area of the tank to be equal to x squared plus 4xh. X squared is the base area and then xh is the surface area of each side, and we have 4 sides. And as the tank has an open top, so there will be no glass there. Let's now substitute the value of h from the volume equation. This gives us a surface area equation in terms of x only. Since our goal is to minimize the resources and therefore the cost, we want to find x that minimizes this surface area. For that, we first find the critical numbers of s by setting the first derivative of this equation to 0. This leads to a value of x which is equal to 0.644 feet. Now let's look at the first and second derivative tests. The dashed line represents the critical number, and if we look at the first derivative curve around this number, we can see that the derivative sign changes from negative to positive, which indicates that this point represents a minimum value. We also see that the second derivative at the critical number is greater than 0, therefore suggesting that this represents a minimum value. Now that we have found the value of x that minimizes the surface area, we can get the optimal surface area, which is approximately 1.245 square feet. We can also get the value of h from the volume constraint, which is 0.322 feet. Now all this calculation is for the internal volume where the water will be stored. We can account for glass thickness when calculating the optimal surface area. Here, the optimal surface area of 1.245 square feet assumes the thickness to be 0, but we can write final x as x plus 2t and final h as h plus t, as there is no glass required at the top of the tank. I hope you liked this video. Thanks for watching and see you in the next video.